All right, we're going to talk a little bit about some symbols. If you all see the symbol limit as x approaches c with a little minus next to it, this is what we call a left-hand limit. And if you see limit as x approaches c with a plus, it's what we call a right-hand limit. Now, these are called one-sided limits because you're only approaching from the left or the right. When you see a two-sided limit written, which is just limit as x approaches c without anything after it, this means if that exists, so if we have limit as x approaches c of, let's say, a function f of x equals some limit, if the limit exists, then, or sorry, the limit exists if both the one-sided limits so both the one-sided limits have to exist and are equal. So the one-sided limits have to not only exist, but they have to approach the same number. So we'll look at a couple quick cases of this. Let's say we had just a quick graph here, something like that. And let's say maybe 1 is here, and 2 is here, and we get 0, we get 1, we get 2, and 3. So let's say we're kind of like this. Limit, in this case, limit, let's say this is a function f of x. Limit as x approaches, see that's supposed to be over the 3. So let's say limit as x approaches 3 from the left. So that would indicate that you're approaching 3 from the left. So your y values are approaching like this. Limit as x approaches 3 from the left is 2. The limit as x approaches 3 from the right, if you're approaching 3 from the right, you're approaching 3 from above. In terms of the y values, you would be approaching from above. In this situation, the y values as you approach from above also equal 2. So in this case, the left limit and the right limit, they both equal 2. So we can say, oops, I really should be putting f of x is in there, so it's clear what function the limit is we're talking about. So then we would say the limit as x approaches 3 of f of x equals 2, because the limit as x approaches 3 of f of x, the left-hand limit is 2, the right-hand limit is 2, so they both exist and they're equal to 2. So we could see that the limit as x approaches 3 of f of x equals 2 in this situation. Let's look at one of these where the limit has issues. The one-sided limits exist, but the two-sided limit doesn't. So let's say we had a function that, I don't know, let's see, maybe it's just a horizontal line at 1 up until we get to 2, and it stops with a closed dot at 2. And then it picks up, let's see, that's 2, 3, 4. Then it picks up with an open circle here and just kind of continues on like that. And I want to know what's the limit. Say this is the function f of x. What is the limit as x approaches 2 from the left of f of x? And what's the limit as x approaches 2 from the right of f of x? And then what can we say about the limit as x approaches 2? So what can we say about the two-sided limit? Okay, so as we approach 2 from the left, we're getting closer and closer to 2 from the left. So we're getting closer and closer here to this point. So our y values are staying at 1. So as we approach 2 from the left, we get 1. As we approach 2 from the right, now our y values are up here, and the y values are approaching the value, let's see, it's 1, 2, 3, so they're approaching the value 4. So the left-hand limit is 1, the right-hand limit's 4. In this case, the two-sided limit does not exist. And why doesn't it exist? Well, we said this limit is x approaches c of f of x. That if the limit exists, if both the one-sided limits exist and are equal. So we got, in this situation, we had both the one-sided limits existed. They were 1 and 4. But since they weren't equal, the two-sided limit doesn't exist. So that's a little bit about one-sided limits and their relationship to two-sided limits. For the regular limit to exist, you need both one-sided limits to exist and be the same number.